Okay, this is exercise set 1.2. The title is Systems of Linear Equations, 2 Variable. Calculator solution using the graphing feature of the TI-84 Plus. We're encountering single point solutions in this exercise set. The exercises we plan to do here are numbers 1, 2, and 9. The instructions are here. Part A. Is the system linear, 2 variables? If not, state this and explain the reason. If so, proceed to answer parts B and C below. Alright, so if we do have a linear system, 2 variables, we would go to part B here, which is solve the system using the graphing feature of the TI-84 Plus calculator. Record what you have entered into the y equals 2 edit screen. Record exact answers if you are able to by using the calculator's fraction conversion feature. If not able to do this, explain the reason and then record decimal approximations rounded to 3 significant digits. Part C. Use the calculator to perform an algebraic check of your solution. Record the result. Alright, let's go to exercise 1. Okay, here in exercise 1. Let's look at the first equation of the system, and since this has the form ax plus by equals c, that's a linear equation, 2 variables. The second equation, 3y minus 2x equals 6, okay, if we just transpose the x's and y's here, this also can be seen to be equivalent to the form ax plus by equals c. It's linear, 2 variables also. Alright, that makes our system, indeed, linear, 2 variables. We can answer part A. Yes, this is a linear system, 2 variables. That makes us responsible for solving the system with the calculator, which is what part B is all about. Alright, solving a system. Graphically, we're trying to find the intersection of these 2 equation graphs here. To do that on the calculator, the first order of business is to solve for y in each case so the calculator is able to sketch the graph. Let's take this first equation. To solve for y, which means rewrite this equation so that y is isolated on one side, we need to subtract 8x and then divide both sides by 9. We could have a y1 equal to 72 minus 8x, the quantity, divided by 9. Okay, in the second equation, to solve for y here, could add 2x to both sides, divide both sides by 3. We'd have y sub 2 equaling 6 plus 2x, the quantity, divided by 3. Alright, we're ready to go to the calculator. Alright, at the calculator, let's go to the y equals 2 edit screen. We have our formula for y1. It would be parenthesis 72 minus 8x parenthesis divided by 9. Okay, for y2 we have parenthesis 6 plus 2x parenthesis divided by 3. Alright, now as an initial graph we might use the coordinate system that has x going from negative 10 to positive 10 and y going from negative 10 to positive 10. In the TI-84 Plus, that's called the standard coordinate system, and to get that one up and running, go to Zoom, and number 6 you see is Zoom Standard. That's what we would like, that coordinate system, so press 6. Okay, this coordinate system is working real well for us because the intersection of the two graphs, which is what we want, is already visible right here on this coordinate system. Okay, now we need to go and try to get that calculated. For that, second, calculate, intersect. Okay, now we'll have 3 questions to answer for this. Right now, I see the calculator cursor is up here. I'm going to just move it over to the right a little bit to more clearly see what's going on. Okay, now the question, which is down here in the lower left corner, is this our first curve of the intersection? Sure, it can be. So we can say yes by pressing enter. Now the calculator cursor jumped over to this other straight line, and it's asking us, is this the second curve of our intersection? And we say yes by pressing enter. Now the calculator is asking us to take a guess as to what the intersection is. It needs us to do this graphically, so we need to move that calculator cursor over, which you do by hitting this navigation key. Let's go over to the right. About there. That looks like a pretty good guess. And when you have your guess, enter. Alright, so here we have this these decimal numbers here. We are trying, if we can, to get exact answers. So let's try that. For this, we'll need to go back to the home screen. Second, quit. Let's examine that x. Go to the Math menu. Let's try using this fraction conversion feature. It's number 1. Since it's already selected, we can just press enter, which will paste it on the home screen, and then enter again, which executes the instruction. Okay, it looks like x is actually exactly equal to 27/7. Okay, maybe y can also be written as an exact fraction. Let's find out. Alpha y math fraction enter. Okay, there we are with an exact y. Okay, we're ready to record on paper the solution to this system. Let's do that. So we can write the solution is x coordinate was 27/7. The y coordinate 32/7. Now, since this is a very conclusive statement here, I want it to jump off the paper so the person reading this can see the most important conclusive statement. So I like to use a cloud like that. Okay, there we are. Now, let's check this answer over, because, there's 2 sources of error that we have going on here, right? One would be the solve for y algebra that we did in those cases there. That could have been, there could be errors there. Secondly, putting this y1 and this y2 into the calculator, keyboarding, another source of error. So, certainly, we would like to check this over. For a situation like this, one of the most powerful checks you've got is using the original equations. Now, let's take the left-hand side of each of these original equations, and we'll have the calculator compute and see what it gets for the right-hand side. The second equation's left-hand side is 3y minus 2x. Let's see what the calculator says about that. Okay, at the calculator, we might just clear the home screen here. And let's proceed with the first left-hand side. That's the 8x plus 9y and push enter. 72. Oh, good. Okay, just like the original equation. That's one of our checks. Now for the second one, we have 3y subtraction 2x. And enter. 6. Just as in the first original equation. Okay, let's record our check that we've got now. So, with the calculator, we have got that 8x plus 9y turns out to be 72, just as in the original equation. That's a check. And 3y minus 2x turns out to be 6, just as in the original equation. That's a check. Alright, there we go. Now, anybody looking at our solution will be pretty convinced that this is indeed correct. Alright, let's go to exercise number 2. For part A, we're going to have to decide whether or not this is a linear system, two variables, or not. Alright, so we take a look at this first equation, and right here, x times y, sometimes called a cross product term. That's not linear. You remember, for linear, you basically can only have constant multiples of x, constant multiples of y, and constants. You can't have a cross product of x times y. Alright, so this is a problem right here. Sometimes you can recover from such a problem by doing some algebraic manipulation, but here it doesn't look too good. For example, maybe you come along and say, well, I will divide both sides by x. How about that? Alright, so let's divide each term here by x. This would become just a y plus this divides by x. That only leaves 7 behind, equals 2. 3 divided by x. There. Now you can look at this equation, which starts off okay, y plus 7, but here you go. 3 divided by x, you can't have that and be linear. No divide by x's are permitted in a linear equation either. Okay, so maybe you say, wait, one more thing. Maybe divide both sides by y. Okay, if we try that, this would become, let's see, divide each term by y. This would leave behind x. This becomes 7x over y. And then over here you have a 3 divided by y. Alright, well, although this is just x, now we've got an x divided by y term and a 3 divided by y term. Two problems have occurred. Alright, so it looks like this first equation is nonlinear, and that defeats the entire system as far as being linear goes. We can write here for part A that no, this is not a linear system. We're supposed to explain why. Okay, so here comes our reason. Well, we can basically say that the first equation has an xy term in it. That is what really defeated this as far as being linear. Okay, so the first equation has an xy term. Thus, the system is nonlinear. Okay, so you want to be sure you can identify a linear system from a nonlinear system, because how you proceed mathematically in each case is different. Okay, and that's it for this question, because we are not responsible for solving any nonlinear systems. Let's try exercise number 9. Okay, to get started, is this linear two variables? Okay, let's start with the first equation. This equation actually has the form directly. ax plus by equals c. That's linear. The second equation, also already in the form ax plus by equals c. That's linear. Okay, so we're ready to say right away that yes, this is a linear system of equations. We can say the elaborate version. Two variable. Okay, now we are responsible for trying to solve the system. Okay, with the calculator assistance. To do that, alright, we'll need the graphs of these equations. To obtain them on the calculator, we need to have y solved for in each case here. Let's start with this first equation. Looks like we could subtract 2x from both sides, then divide both sides by 5. We could have a y1 equaling to negative 100 minus 2x, the quantity, divide by 5. Alright, in the second equation, pretty simple. Just subtract x from both sides. We have a y sub 2 equal to 30 minus x. Okay, we're ready to go to the calculator. Alright, let's go to the y equals 2 edit screen. We have obtained for y1, parenthesis. Now, here's where you want to be a little careful. Notice I have the negative 100 there. I do not want to use this subtraction sign. I do want to use the negative sign down here. There, negative, and then 100. Now I am to subtract, subtraction, 2x, parenthesis, divided by 5. While we're here, let's look up close at the screen here for a moment, and you'll notice a negative sign here. It's only 3 pixels across, and it's a little above the center line of this formula line here. Compare that to the subtraction sign. It's 4 pixels, a little longer than the negative sign, and it's also written right at the middle of the formula line here. So even after you do your keystroking, you can take a look at the calculator. If you look closely, you can distinguish a negative sign from a subtraction sign. Okay, let's go on then to y2. For y2, we had 30 minus x. Okay, let's try taking a look at a standard coordinate system. X-axis, negative 10 to positive 10. Y-axis, negative 10 to positive 10. We do that by going zoom 6. Absolutely nothing appears. Okay, what to do? Well, a couple of things you can do. One of my favorites in an attempt to just get something to appear no matter what is to use this zoom fit feature on the calculator. Zoom fit is going to leave the x-axis alone. It's going to stay negative 10 to positive 10. But it's going to change the y-axis to whatever it needs to get entire graphs to appear. Alright, here's how we get this. Zoom. Now you notice you don't see a fit on the menu right there, but you see this little arrow. It's telling you there are more choices below. Since it's our first time doing this, let's actually go down and see what we've got down here. So, oh, there it is. Zoom fit. You notice it's number 0. So although we could just push enter this way in the future, I usually just go zoom 0 to do this. Now let's see the result. The result is 2 graphs do appear. Alright, 2 straight lines like we're expecting. However, we want the intersection, and that is not in sight. But we see that it appears to be off to the right somewhere far away. Okay, that means we need to change the window. We need more positive x-axis, because we can tell from the way these lines are sloped, they're going to intersect far to the right. Alright, we go to the window, and x max, that's what's controlling how much positive x-axis we have. What shall we do here? Just take a guess. Maybe 200. And before I just push graph, I do something else. Because when I have this much positive x-axis, I'm thinking this intersection's probably going to go off the graph display again. So another idea to also use here would be to zoom fit. So zoom 0 as well. Okay, there we are. An intersection is in sight. Now we can go and calculate it. Second, calculate, intersect. Okay, now just to be clear about all my decisions or my answers to these questions, I'm going to move that calculator cursor a little bit to the right so it's not in such a congested area, and answer the 3 questions. Is this a first curve for our intersection? Yes, press enter. Is that a second curve for our intersection? Say yes by enter. A guess. Alright, now I do need to move the calculator cursor over and make a reasonable guess at the intersection about there, and enter. Okay, these numbers here appear on the calculator display. The instructions have us attempting to get exact answers. For that, let's go to the home screen and try using the calculator fraction conversion feature. Let's take x first. Math menu. Paste fraction on the home screen there and press enter again to execute the instruction. Okay, 250 divided by 3. Great, got an exact coordinate there. How about that y? Alpha, y, math, fraction, go. Okay, negative 160 over 3. Great, we can write an exact solution for this now. Okay, we have here that the solution is, the x-coordinate is 250 divided by 3. The y-coordinate is negative 160 over 3. Since this is a conclusive statement, I like the prominent cloud so that this just jumps off the paper for anyone reading the solution. Now, maybe we've made an error here, right? 2 sources of error are going on here. One, the solve for y step in the beginning of this question. A couple things that could have gone wrong there. Secondly, putting this into the calculator, the keyboarding, another source of error there. Alright, so certainly we want to be checking over our answer here. What can we do? Powerful check in this situation is to go back to the original equations. As if this is really a solution, upon substitution, should make each equation true. So let's take the left-hand side and have the calculator compute it and see what it comes out to. Second equation, the left-hand side is x plus y. Have the calculator compute that and see if it can come up with the right-hand side of the original equation. Alright, we're ready to go back to the calculator. Alright, here at the calculator, perhaps we clear the home screen, and let's take the left-hand side of that first equation. That's 2x plus 5 alpha y, and enter negative 100, same as the original equation. Great, that's one check down. One more to go. It's x plus y, x plus alpha y. Enter. 30, just as the original equation. Great. Let's record this result on our paper. We did the 2x plus 5y on the calculator, obtained the negative 100, just as the original equation. That's a check. And secondly, we did x plus y on the calculator. It came up with a 30, just as in the original equation. That's a check. So now we can be confident, and so can anyone reading our solution be confident that we have it right. Okay.